Okay, so imagine you're running a huge factory floor or maybe a high-security server facility.
Right.
You've got one single powerful computer that has to be locked away in, say, a climate-controlled vault for safety.
But you still have people who need to use it.
Exactly. Operators on the other side of the building, maybe 1,000 feet away.
And you can't just, run a super long HDMI cable. The signal just falls apart. The lag would be unusable. It's a real logistical nightmare.
It is. So today we're doing a deep dive into a piece of hardware that claims to solve that exact distance problem. We're looking at the NTI VOPEX-C5USBVA-4.
It's a bit of a mouthful.
It is.
Yeah.
Our mission is to figure out how this little steel box lets up to 8 users control one PC from like a quarter mile away just using standard Ethernet cables.
It's technically called a VGA USB KVM splitter and extender.
All right, let's break it down immediately. KVM.
Keyboard, video, mouse. It's a standard term. It just means a device that lets you control a computer from a distance.
And the VOPEX part.
That's the splitter function. It doesn't just send the signal to one person, it broadcasts it, allowing up to 8 remote users to control that one host machine.
And the specs say it does this over C85 cable. That's just regular Ethernet cable, right? The stuff that's been in office walls for decades.
Exactly. And that's where the real engineering challenge is. How do you push a high-res video signal 1,000 feet over copper wire that was never really designed for it?
Because usually when you do that, you get all that, ghosting or color bleed. I've seen it on cheaper setups where the text almost looks like it's vibrating.
That happens because inside the cable, different colors, red, green, blue, they actually travel at slightly different speeds.
Ah,
Up for 1,000 feet, the red signal might get there a fraction of a microsecond after the blue. And that creates a blurry, messy image.
And this device, it claims to fix that automatically.
Yes, that's one of the key features. It has automatic video quality and color skew adjustment. It electronically delays the faster signals just enough to match the slower ones.
So it syncs them up.
It syncs them up. So even at 1,000 feet, you're still getting 1920 by 1200 resolution at 60 hertz.
That is surprisingly sharp. Now, I saw another term in the specs that sounded like a total headache. DDC, emulation and mixing.
Right. DDC is display data channel. It's basically the digital handshake where your monitor tells the computer, hey, I'm a 4K screen, or I'm an old 720p monitor.
But here you could have 8 different monitors plugged into one computer. What if one guy has a brand new widescreen and someone else has an old square one? Doesn't the PC get confused?
It usually would, yeah. The computer would likely just give up and default to a black screen for everyone, or the absolute lowest resolution. The mixing part here is clever. The device asks all the connected monitors what they can do, builds a table of resolutions that are common to all of them, and then tells the computer to use that safe common standard.
So it prevents that black screen of death just because somebody plugged in an old monitor down the hall?
It ensures total consistency. Everybody sees the interface.
It's not just video either. The documents mention it also broadcasts stereo audio and has local USB ports.
Which is huge for industrial use. If an alarm sounds on the host machine, you need the operator 3 football fields away to hear it.
And the USB ports.
That's for things like barcode scanners, printers, maybe even a security camera at the remote desk.
I also saw it supports smart boards and touch screens. That tells me this is not for gamers. This is for control rooms, logistics hubs.
Absolutely. The build quality points to that too, and so does the price. It's listed at $795.
That feels steep for a splitter, doesn't it?
It does, until you see what it's made of. It's a ruggedized steel box with a powder coat finish. It has built-in surge protection.
So you're paying for reliability.
You are. In a factory, if some cheap plastic hub fails, you can shut down an entire production line. This thing is built to take a beating and keep working.
It also comes with a 2-year warranty, which says something.
It's meant to be a set-it-and-forget-it piece of kit.
So, to sum it up, we have a steel box that lets 8 people run one computer from a quarter mile away, and it handles all the messy physics of signal decay so the users never have to think about it.
It's a robust solution for a very specific problem: multi-user data entry in harsh or secure environments.
Which brings up an interesting final thought for you to consider. We are all obsessed with the wireless revolution, 5G, Wi-Fi 6, everything in the cloud. But when heavy industry needs to guarantee that a system works 100% of the time, they don't trust the air. They use steel boxes and copper wires.
Because physical connections still rule when reliability is the only feature that really matters.
Something to think about the next time your Bluetooth headphones cut out. Thanks for joining us on this deep dive.